ProModel is excited to release the latest update to our ProModel Optimization Suite Autodesk Edition that links directly with AutoCAD and Inventor. Using AutoCAD with factory design utilities, we can build a digital twin of our process. Start with a blank canvas to build your initial layout with factory assets, or use an existing AutoCAD drawing with factory assets. Then, from the ProModel ribbon, using the Simulation Browser and Simulation Properties windows directly in AutoCAD, turn your drawing into a model of your factory process by adding equipment locations, conveyors, entities, flows, and resources with path networks to replicate your work cell or production line. Assets from your Autodesk Factory Design Utilities library can be used to define the machine or station locations and conveyors that entities in your process line will pass through. Entities in the model represent the raw materials or parts that will be processed in the facility, in this case, the spade or shovel. Flows help you define the sequences through the equipment locations that your entities need to take. Resources represent additional equipment, devices, or people that support your production line. Here we have 3 different types of workers and a standard AGV. Path networks define the routes on which the resources may travel to do their work. In this case, we have 2 path networks, one for the workers and one for the AGV. We can now simply open this model in ProModel from the ribbon and run the simulation by hitting play, or add more complex processing characteristics if required, such as arrival patterns which dictate how parts enter the system, and processing logic, which determines when and how the entities can move to the next location and what happens to an entity when it gets there. In this example, we've just finished building our production line model in AutoCAD. We'll run a baseline scenario inside ProModel to ensure that our process model reflects our facility's current output. The animated simulation helps us to visualize our current production line to better understand how it's functioning. And by using an AutoCAD drawing with factory assets, the ProModel Simulation Digital Twin is a spatially accurate scaled model. This ensures that any recommendations that ProModel is validating will fit in the AutoCAD layout. When the simulation is complete, the ProModel Output Viewer allows us to build a dashboard of reports from the simulation analytics to focus on the metrics that suit our business goals. In our example, our business has asked us to grow production by 30% over the coming year. ProModel allows us to study alternative options to improve throughput. In this case, we've determined, based on the simulation, there is a throughput issue at the thread cutting machine, preventing our production line from reaching our required increase in output. We'll try some different scenarios to determine the most cost-effective way of removing the bottleneck so we can meet the increased production requirement. In our example, the bottleneck is at the thread cutting machine. But what's the cause of the bottleneck? To answer this question, we can compare the addition of an extra worker with the addition of an extra thread cutting machine, or the addition of both. We add the third worker and second thread cutting machine in AutoCAD, and thanks to the linkage between the drawing and the model, changes made in AutoCAD will sync with the simulation model simply by opening the drawing in ProModel, then simulate to generate updated results. Our baseline report shows us that the thread cutting machine's buffer has a high number of components. Showing the alternative of adding an additional thread cutting machine, we can see that this doesn't solve the problem of the buffer being full and has no effect on the throughput of the production line. Showing the addition of an extra worker, we can see that the worker can clear the buffer and remove the bottleneck, which is good news. However, the throughput for a single thread cutting machine has only increased from 278 parts to 310. A 12% increase, but below the 30% we've been tasked to find. Our final scenario compares the addition of both an extra thread cutting machine and an extra worker. In this case, we can see that the worker can steadily clear the buffer of both thread cutting machines, increasing the throughput from 278 parts to 376 parts, an increase of 35%, well over the 30% target. In this case, we find that the optimal solution is to add both an extra operator and a new thread cutting machine to remove the bottleneck and increase production to meet our target. Not only do we have an answer to our problem, but we have the analytics to demonstrate how we found the solution and make our case to management for a new hire and capital expenditure to meet the desired production target. With ProModel, AutoCAD, and Autodesk factory design utilities, you can design optimized factory layouts faster than ever before. Get your 30-day evaluation copy from the Autodesk App Store.